Okay, there's an upward force of 0.0120 newtons on a charge inside a downward field. Ooh, we got a downward field. So it's an upward force, but a downward field. So it must be a negative charge. But let's draw a picture here. A vertical, I like to draw this picture. So let's see, whoops. Okay, now I feel like I held the shift key down for that. Okay, it's an upward force, but it's a downward field. So if it's a downward field, that means there's positive charge on top. That's positive too. Negative charge on the bottom. That would make it a downward field, right? But if there's an upward force, this must, of course, be a negative charge, right? Because it would be attracted to the top, repelled by the bottom. Okay. We don't need to do that to actually get the the right answer, but I'm just throwing that out there. Okay, so let's see. What is the charge? Is it positive or negative? So E is F over Q. So therefore Q will be F over E, right? So Q is equal to upward force. Okay, how do we do, let's do the signs here. Let's make upward positive, because that's the most, right? Downward is negative, upward is positive. Now talking about the charge, I'm just talking about the direction here, okay? So Q is equal to force, which is 450, 450 newtons per coulomb, but it's down, right? So I'm going to say negative, right? Divided by the electric field. What am I doing? Q is equal to, let's try this again, force over electric field, okay? The force is upward, right? So it's positive 0.0120 newtons. The field, though, is downward, so negative 450 newtons per coulomb, right? And of course, that'll end up being coulombs. Notice that because we have a positive force, but then we have a negative field here, that's going to end up being a negative charge. Not that we needed that, but there it is. Okay, so 0.012 divided by 450 is negative 2.66666 times 10 to the minus 5th coulombs, or 26.7 microcoulombs, right? That's how you actually probably write it, but that's also true, right? All right. Woohoo!